Hi again. In this tutorial, we will go deeper in some special material stuff. And here we will talk about displacement maps. Just for short introduction again, I guess I showed you this image in another tutorial, but just for the difference, you are already now familiar with the bump and normal mapping. You see that the results are similar. The bump map is actually a grayscale map and the normal map is an RGB map, which is actually better most of the time. The normal maps are then bump maps, but actually I just try around and I'll see what is best for my need. And today we will have a look at the displacement maps, because when you want to do really rough structures and not just giving a little bit of roughness like the bump or normal map, I mean really hard structures, you can simulate with the displacement map. And they work a little bit different in Maya. So what I prepared here is actually just for a better comparison. I have here a material, as you all know. I have the color in, I have, oops, I did the roughness map here on the wrong position. Break connection. I need it here, the roughness map, so just a quick revision. So roughness. And I have the bump map here, and I used here actually the displacement map because this is a black and white map. I also have a normal map. You can also use that, so it depends which result is better for you. I had the feeling that the displacement gave me a better result, and I have here a bump depth of 0.5, and that's the result. And now I will show you at this ball here, or the sphere, what we can do instead, or to get a better result. So I don't put anything here in the bump mapping. Instead, we are here, I just named it brick displacement. And what you do, you just go here on this symbol where we get actually one step back. And there we have actually the surface material. It's connected here. And there we have also the displacement material. And here we do actually the same stuff here. We get here a displacement and another place where we can add here the bricks displacement. And now let's see, I just save the image and see what will be the difference. So this is what we got. When I compare the images, you see that my ball expanded actually, because the displacement map is really deforming the geometry, and it's maybe a little bit, you see it, it's way too hard. So I have to check that the effect isn't that hard. So I go back into my displacement here, and so I have to go here inside, and then I check here my scaling, and I put it to 0.1 and try again. Now we have a better result actually, and so this is the comparison of the scale, but I felt it was too less now. So again, go here inside and here inside, and I may try 3 or 2. Let's check. Now we have our result with the 0.3 of the scale. Maybe it is sometimes a little bit too hard, but you see actually what is happening. Okay, that's just the difference here. between 0.1 and 0.3, so that it's getting really deep. And what you see is also that the sphere isn't a perfect sphere anymore, it's really deformed. And you also recognize that it got bigger because, yeah, I just said it again, that the geometry is deforming. Well, I think you got the idea. You know how to use displacement if you want to create really hard structures or really rough structures. And I just put my bricks here on the wall and see what will be my result. So this is my final result. You see, not too bad, but I'm not sure if this kind of brick is here the best decision or the best solution for the wall. So, but just for demonstration purposes, you see what the effect of the displacement map is. Well, that's it.